placed in Navi Mumbai. I am on behalf of IWSA, I'm here to welcome all to the 58th talk under Science and Our Life webinar series supported by Board of Research in Nuclear Sciences under Department of Atomic Energy. It's my privilege to welcome our most talented speaker, Dr. Soumyadeep Mukherjee, who will share his insights on the fascinating world of astrophotography. Today's topic being shooting stars, discussing the basics of astrophotography. Before we delve into the wonders of the night sky today, let me quickly share a brief on IWSA. Our organization was started on 13th June 1973, and we just about completed our 50 glorious years. Founded by 12 young women in science with the main objective to reach science to the masses. This is an all India social welfare, voluntary, non-profit, secular, non-political organization having 12 branches across India. Main mandate to popularize science and science education and practices through lectures, exhibitions, competitions among school, college, and community levels. At the headquarters, we provide a working woman hostel, a daycare, a nursery, a library, computer education center, and a health center, besides early childhood care and education program, scholarship for the financially but meritorious students, financially needy but meritorious students, and lastly, internship programs. Now, today's Science and Our Life series is one such activity that helps us achieve our mandates. SAOL helps us to understand science in everyday life. It was conceptualized to bring to fore how science has influenced and shaped human lives in a big way, be it in relation to health, finance, education, environment, history, architecture, etc. IWSA's endeavor is to invite eminent scientists and personalities on this visual platform and explain the interesting facts in a simple way. I now move on to introduce our speaker, Dr. Soumyadeep Mukherjee, whose incredible profile portfolio you would have already seen along with the flyer. An award-winning astrophotographer, an astrophotography educator, columnist, freelance contributor in astronomy, an amateur astrophotography magazine, holds a doctorate degree in linguistics from IIT Kanpur. His work extends to the subgenres of nightscape, deep sky, solar, lunar, and optical phenomenon photography. He has conducted numerous workshops and treasures more than 200 image print publications across 50 books, magazines, and newspapers, including Astronomy, BBC Sky at Night, Sky and Telescope. His work have appeared in various websites, including National Geographic, NASA, and Forbes. Sir, we are indeed fortunate to have you here with us, and we are jet set to blast off into the mighty universe and curious how you capture the wonders of the night sky. Ladies and gentlemen, a small request. Please maintain a distraction-free environment so our speaker can share his insights without interruption. Please ensure your microphones are muted till the question answer session. Your cooperation is greatly appreciated. Sir, the screen is all yours now. Thank you so much.
Thank you so much for this wonderful introduction. It is really an honor and a pleasure to be a part of this lecture series. And just a request to everybody, please do not call me sir. I'm not very used to it. Soumyadeep is completely fine. Okay, so I'll go ahead and I'll share my screen. All right. All right. Just to check, is it visible?
Yes.
Okay. All right. So thank you once again for allowing me to speak in this lecture series, which is again an honor. Good evening, everybody. It is the topic that I'm going to discuss about is, of course, astrophotography. All of you know about this by now. But the term the term that I chose for the title, shooting stars, is we normally attach shooting stars with meteors. But here the shooting term means photographing. We often call it shooting too. So it's a kind of has a dual meaning, uh, so that it signifies both of them. Of course, 45 minutes or an hour is, of course, not enough to discuss the basics of any subject, and astrophotography is also included. But what I'll try to do is provide a brief overview of what astrophotography is, the kind of things that we astrophotographers do, and how you can, begin doing astrophotography. All right. So the very basic thing, what astrophotography is. So the term astrophotography is taken from two individual terms. One is astronomy, and the other one is, of course, photography. So both of these terms are coming together, making astrophotography. So astrophotography is photographing any kind of cosmic object. That could be anything that lies in the sky, beyond Earth. That could be the sun, as close as the moon, or maybe, far distant as galaxies or nebula or stars, or, comets, meteors, everything that is there above us. And this is a kind of genre in photography, which of course includes astronomy. Now, I've often been asked the question, is the knowledge of astronomy is required, or a formal education in astronomy is required? Nobody, unfortunately, asked me if formal education is required in photography, but since the term astro is there, this question I've faced numerous times. So I wanted to answer these questions to, again, is that the answer would be no. No formal education in astronomy or in photography is required to do astrophotography. But yes, whenever we kind of do any kind of photography, it is very important to know the subject. So whenever we are trying to, say, photograph birds, it is always helpful and sometimes necessary that we know about the bird, the kind of nature that the bird has, the kind of the seasons that it can be seen, it's some kinds of its behavior, and that helps us photographing the bird. Very similarly, even in astrophotography, a very basic knowledge in astronomy would be definitely helpful. But even if somebody doesn't have that kind of knowledge or a formal education in astronomy, we're good to go, as long as we love the sky, as long as we love capturing the sky. Astrophotography can be done by anybody. But then again, I would also like to point out that once we go ahead with astrophotography, it is always helpful that we get to know about the subjects. We get to know about, say, for example, the behavior of the sun, how the moon moves in the sky, some names of the craters of the moon, the kind of nebula that. All right. The kind of nebula that we are photographing, is it an emission nebula? Is it a reflection nebula? Those kind of very basic knowledge. You don't, require in-depth knowledge of astronomy for this. And astronomy, of course, can be done in both nighttime. Of course, 90% or maybe 95% of astrophotography we do at night, after the twilight. But we can do certain kind of photography at daytime also, sun being one of the major subject during daytime. But there are also certain optical phenomena which are not classically a part of astrophotography, but we love to include that within astrophotography. And what I think is one of the most intriguing thing, at least personally for me, that I've chosen astrophotography, is that it has a certain charm, and the charm is in capturing the invisible. If we look at the night sky, if I just go to the terrace, or if I can look out and see, I would see at max a few stars, maybe the moon, some of the bright planets, and that's it. If we happen to go to a dark sky location, we might be able to see a lot more stars, maybe hundreds of them. If we are unfortunately living in a metro city or around a city, we'll be seeing maybe 30, 40, or 50 stars at max. But when we are pointing the camera towards the sky and taking longer exposures, what we are capturing is something that we cannot see with our naked eye. That is a limitation we have as humans, that our eyes are not, they're not eligible, or they're not capable of taking long exposures to collect the photons for a longer time. That instantaneous recording of the light that we are seeing. Now, this capturing the invisible has always been, and it still is very intriguing for me. Whenever I manage to capture, say, a galaxy, and I take a look at it on the back of my camera, I always wonder that, okay, this is there. I'm looking at the same region in the sky with my naked eye, but I cannot even figure out that it is there. But with the camera, I can see it with all its glory, with all the colors, say a nebula, all the red colors or the blue colors of the nebula, or even the details of the moon. When we see the moon with our naked eye, we don't get to see all those craters and all those minor details of the lunar surface. But with a telephoto camera, or even with a telescope, or even if you're looking at it with a binocular, you get to see a lot more. And this is, I think, inspires me a lot, motivates me a lot. And astrophotography is another, I should not call it special, but another charming thing about astrophotography is the merger of science and art. The science part, of course, comes from astronomy. If we look at the history of astrophotography for the last 100 or 140 years, we would see that astrophotography was used as a means to understand the universe. Right from the beginning, when astrophotography started, probably in, please forgive me if I'm saying it wrong, but around 1860 or 1870s, till date, when we are seeing the images from James Webb Space Telescope, what we are doing is we are, discovering new things. We are, uncovering the science behind all those new stars, those new solar systems, or those distant galaxies. Even with amateur astrophotographers, I mean, there has been numerous records when, amateur astrophotography, people like doing the astrophotography sitting at their, backyard or from their rooftop, they have helped, discovering a lot of new things about the solar system. One major, the one I remember immediately is that, so when probably in 1996, when the comet Levi-Shoemaker that crashed onto Jupiter and created a huge mark on the surface of the Jupiter. This was initially or first recorded by an amateur astrophotographer. And then the news went on to NASA, and then they took a lot many pictures, and of course with greater detail with the Hubble telescope. So the science is always there, even if we are not doing anything with the science, we're just taking a picture, but the science is of course there. And of course, then there is the art of photography, those compositions, those individual things that comes out of a photographer. So astrophotography is a wonderful amalgamation of science and art, coming together and making a wonderful image. Now, of course, I'm not trying to be biased since I'm an astrophotographer, but is it special? No. But it is different from a few other genres of photography. How? One is, if we look at most of the other genres, say portrait or say landscape photography, those started as amateur ventures. If we talk about people like Henry Cartier or Ansel Adams going out and taking pictures, those were not kind of to reveal anything, or they were not professional photographers at the beginning. But astrophotography is just the opposite. I would say until the last 40 or 50 years, astrophotography, and it still is being used by professional astronomers. By professional astronomers, I mean those people working in an observatory, in an institute, or say the Hubble, the James Webb, all the space-based telescopes. So these are professional ventures to capture the night sky. But thankfully that, a lot of equipment being available, excuse me, for the amateurs, people can afford to buy all those equipment. It is also available to amateurs. The second thing that kind of differentiates astrophotography with the other genres would be the visualization of the subject. What I was saying earlier is that we cannot see most of the things. Well, we can see the sun, we can see the moon with our naked eye, maybe we can see the stars, but all those dim nebula or the dim galaxies, we cannot see them with our naked eye. So visualization is strictly talking about the photography part, the artistic side. You cannot visualize the astrophotography objects that you're photographing. We take help of previous images. We take help of different surveys, different websites to get an idea of how the final image might look like, and then we go for the photographing part. The techniques involved in astrophotography is, of course, it is not unique to astrophotography. Long exposure photography exists in many other genres, including landscape. But there are some equipment which are unique to astrophotography. For example, telescope, or for example, a star tracker on an equatorial mount. These are the things that are only required for astrophotography. And the result is, again, it's not a special result that we are getting, but I think that the resulting image that we are seeing takes us to travel in space and both time. And I think that is, again, it is special for me personally. And again, I'm not trying to be biased for astrophotography, but I think these are the things that make it, again, charming, if not special, but charming. All right. And what do we capture? When we say we capture the night sky, what are the things that we can capture? The first and the foremost thing, and probably the most common thing, is the Milky Way. I'm sure if you have traveled to dark sky, by dark sky, I mean extremely dark sky, Milky Way is even visible to the naked eye. Of course, not as if you just look at the background of the screen. This is also the Sagittarius region of the Milky Way. You can understand that this region is there as a very faint thing going across the sky. It's a huge thing. It appears huge in the night sky, but all these colors and maybe all those details are not visible with the naked eye. Star trails is a another very common thing, is that we take multiple images pointing our camera to a particular direction of the sky, and we capture the movement of the stars. As we know, due to the rotation of the Earth, the stars move apparently in our night sky from east to west. So we capture that movement, and it is called star trails. Of course, the sun and the moon is there to capture the planets. With moderate equipment, I would say Jupiter, Venus, Saturn, they are most commonly captured. Mercury is a bit difficult to capture, not because it requires special equipment, but it has more to do with Mercury doesn't rise a lot above the horizon. And the Neptune and Uranus, these are the two things that are very, very faint and also small. So one requires a telescope to capture those planets. Galaxies and nebula are, of course, there to capture all kinds of galaxies, all kinds of nebula. Some of them are can be photographed even with a very moderate setup. By moderate setup, I mean a regular photographic setup like a camera and a lens. But some, especially galaxies, because Most of them are very, very far away from us, and they're very small. They appear very small in our night sky. So for those, we need telescopes. And of course, the star clusters are there, all kind of clusters like the globular or the open, all kinds of there. Equipment we need. So this is again a myth behind, and I would say also a reason behind why astrophotography hasn't been so popular like the other genres, is that people used to somehow, I don't know why, even me, I used to take it as that to do astrophotography, I would need all those large telescopes, I would need all those large mounts and observatory and all those things. I would need to invest lakhs, if not crores, for those equipment. But it is completely wrong. I mean, astrophotography can simply be done with just a smartphone. We all have those. So we all are equipped for astrophotography, and that is the best part. And if you happen to have a camera, a basic DSLR camera, or say a mirrorless in this new age, you're pretty much good to go for astrophotography. Any kind of camera will suffice. If you're using a camera, and if you happen to have those even those basic kit lenses, you can do a lot of astrophotography with them. And of course, if you need to take it to the next level, you need to investment is required in the equipment, and there is people call it the gear acquisition syndrome. There is no stopping once you start. You get all those lenses, but it's really not necessary to invest right at the beginning. For accessories, I would say a tripod is a must, since we are capturing it with the help of long exposures. We need to secure our camera, and we want it to be very stable and still as long as we are taking the photo. So a very stable tripod is absolute necessary. Even if you are doing it with a smartphone or a camera or a dedicated kind of any stuff, a tripod is the basis of everything that we do in astrophotography. A telescope is, of course, it's a very good thing to have. You can do visual astronomy with it. You can just enjoy the beauty of those planets, or maybe the galaxies or the nebula. Or you can attach camera or even your smartphone to your telescope and take images. Another very important thing and a unique thing to astrophotography is a star tracker or an equatorial mount. Now, what it does is basically, since I said that we need to take long exposures, and I also said that the sky keeps moving. So in order to allow us to take those longer exposures after a certain limit, is we need something that would help us to counter that movement of the sky. And that is what a star tracker is. A star tracker can be this small, or it can be as big as me, or maybe larger than my size. What it does is we put our telescope or lenses and the camera on top of a star tracker, and it helps us moving the camera along with the sky, so that we are allowed to take longer exposures. And of course, that reveals more details of the sky. I think this is a very important thing about whether regardless of whether you're using your phone or your camera, it cannot be done with auto mode, because whatever the auto mode does, understanding the light of the surrounding or doing autofocus, all the stuff that the automatic mode does, it cannot do it at night. Even if you're using the most professional camera that a brand can offer, they won't be able to do it. So the only way to do is doing everything manually. In some smartphones, it is also called a pro mode. It is basically you are handling all the details. So in any kind of photography, what is also known as the exposure triangle are the three things: shutter speed, aperture, and ISO. So with manual mode, whether in phone or in a camera, you can adjust all these settings on your own. And this is again a basic to photography. In photography, we say that once you have mastered the exposure triangle, your photography is half done. And it is, again, it is very important to astrophotography also, because you need to understand. Now, what is a shutter speed? So exposure triangle is made up of these three things: shutter speed, aperture, and ISO. Shutter speed is basically how long you're exposing your camera sensor to the sky. The longer you expose it, the more photons you're able to collect. It is just like a bucket. The more you keep it in the rain, the more water you'll be able to collect. The aperture is of a lens. It is basically the opening of a lens. The larger it is, the more amount of light will come in a small amount of time. And the smaller it is, we are collecting lesser photons. If I go back to the bucket and rainwater metaphor, it would be the opening of the bucket. If we just have a very slim kind of cylindrical small water bottle in the rain, we won't be able to collect as much water as we would have wanted. But with a gamla of a huge opening, we'd be able to collect more rainwater. So basically, we are again collecting the photons with a larger opening. So larger the aperture, better it is. And ISO is basically a very camera internal thing. It is the sensitivity of the sensor. The larger the ISO, the image appears brighter. The smaller the ISO, the image appears darker. And these are the three things that it is necessary to understand how they work, how they interact with one another, and how they impact the image. So one has to know how increasing the shutter speed, how it will affect the image, or increasing or decreasing the aperture. And that is very basic for any kind of photography, not just astrophotography. Focal length is basically focal length of the lens. The larger the focal length is, the further details are resolved, or we in a layman's term, I would say the closer that we reach to the object. And the wider the focal length is, we stay away from the object, but we capture a larger field of view. The very interesting thing about astrophotography is, for any kind of focal length, there is a subject. If I have a wide angle lens, say, if I go back to the kit lens, 1855 lens, I have the Milky Way, I have the star trails, I have the constellations, everything. If I have a larger focal length, say a 3000 millimeter telescope, or a 600 or 800 millimeter telephoto lens, I also have a subject. I might have those sun and the moon, or those small galaxies, or the nebula. So whole throughout the range, starting from the widest possible, I think 8 mm or 10 mm focal length, to the maximum you can imagine, maybe 10,000 mm. There is always a subject in astrophotography. So, again, from my experience, I've seen a few people talking about that I do not have the perfect focal length for astrophotography. I don't have the lens. That is completely wrong. There is always a subject. Now, the types of astrophotography, I'll skip this thing and I'll go straight to the images. So the first type, or shall we call it the subgenres of astrophotography, is nightscape. So nightscape is basically, it's a combination of astrophotography and landscape photography. So we are doing, so in an image, there would be a landscape element, and then there would be sky, and both has to complement one another. So if I look at the image at the left, so this is the Milky Way arch. This is the Sagittarius region and the Sagittarius arm. And this is the Cygnus region and the Cygnus Orion arm. And this is a landscape. And if I look at the image on the right, okay. Yeah. If I look at the image on the right, this would be a star trail. Again, this is a landscape region, and this is the sky region. So a combination of both the landscape and the sky is what comes here in nightscape photography. And again, this is probably one of the most common kind of astrophotography that people do, since You do not need any specialized equipment. Of course, you can use a star tracker to get a better result of the sky, but you can do it without even a star tracker, just with your smartphone. So this is the most popular choice, and I would also say beginner-friendly choice if you're into astrophotography. The next is I would say, a new addition to astrophotography, something we call deepscape, which is a combination of deep sky and landscape. Now, if we look at these images and compare it to the previous images, we are not looking at a wider field of view. We are rather narrowing it down with a higher focal length. By higher focal length, I mean anything above 85 mm, and it can go up to anything up you can imagine. The goal of deepscape photography is to capture deep sky objects. So here we are seeing the Andromeda galaxy, and here we are seeing the North American Nebula. So the goal is to capture these deep sky objects along with landscape element. Deepscape is a little bit more technical than nightscape. Of course, it is a part of nightscape, but it is a little bit more technical and a little more challenging, I would say, because again, since you are using a longer focal length, now the criteria of a star tracker comes in, and you can do nightscape at any time of the night, but deepscape photography can only be done depending on the object or the subject that you are shooting, only when it is rising or it is setting, because the field of view is very small. You cannot shoot a deepscape when the object, say, is right above your head at the zenith. The next, and probably the most popular and the oldest form of astrophotography, is deep sky astrophotography, where we capture the deep sky objects, anything that is beyond the solar system. That could be a nebula or galaxies or star cluster. So here it is a nebula. It is called the Rho-Fuji cloud complex. And this is a galaxy, a very distant galaxy called the NGC 6744. This region, if we had to put it into perspective, if I just go back, it is this region. This is the exact region. This is a wide field view. If you look at this star, this is the very bright star Antares, and this is exactly portrayed. This is Antares. So it is a more zoomed in view and a more detailed view of the region. And every time I look at this image, I wonder how colorful our space is. But unfortunately, we see it all black. Planetary is again a very old form of astrophotography, where we capture the planets, all the planets. This is the image of Jupiter. You can see the GRS, or the Great Red Spot. And this is actually a time-lapse image, an image taken over maybe 30 or 40 minutes, or maybe more. And you can see these moons. This is one moon. This is Europa. And this is another moon, Ganymede, which is the largest moon in our solar system. And you can see the movement. You can see now Europa is here in the first image, and in the last image it is, eclipsing Jupiter. This, I don't know, this maybe is going farther towards the right. Yes, I think it is going. Ganymede is moving. So both it captures the movement, and also a little bit about the rotation of Jupiter. As we know, Jupiter rotates pretty fast compared to Earth. So if you, in the first image, if you see the Great Red Spot right at the left edge, but after, say, an hour, it has moved almost towards the middle. I'm sorry, should I carry on, or was that?
Yes, sir,
Carry
please.
on, sir.
Okay. Solar is, of course, it is a form of planetary, because the techniques used for planetary are also employed in solar and lunar, but I prefer to call it a separate subgenre, because the subject is completely different. The timings are also different. So this is an image where we are comparing the apparent sizes of the sun during perihelion, when it's closest to the Earth, and aphelion, when it is furthest from Earth. These black dots are actually sunspots. Sunspots are normally not visible with the naked eye unless it is a huge sunspot. And you can only see it either during sunrise or sunset with the naked eye. But it's you have to be very careful when you're looking at the sun. Never look at the sun directly or point your camera towards the sun directly unless you have a solar filter attached to your camera or holding in front of your eye. You can look at it or point at it when during the sunrise or sunset when it is just near the horizon. It is safe to do that. But unless, I've seen a few examples where they have, wrongly pointed the camera towards the sun, and within a few seconds, I think it was on fire because you're focusing all those bright light into a small spot, so it gets really hot. And if you look at it, your eyes can be damaged irreversibly. So be very, very careful if you're doing solar photography. Lunar photography, it's again a form of planetary, but you can, of course, merge landscape elements. So this is a image of the lunar disk taken during, I think this was during twilight. And this is a moonrise image. It's very pleasing, very soothing. You're not, moon, we always, heard a lot of stories about the moon from our childhood. We always have our own cultural myths about moon. So it's very great to, capture the moon and the craters and those details, the seas of the moon, and, connect them with all those stories. It's fun. Lunar photography is very, very fun, at least to me. And of course, then you can photograph a lot of celestial events. By celestial events, you can, I am talking about eclipses, or what is shown on the left image, it is a conjunction between Venus and Jupiter. This is a time slice taken over 10 days. This is an example of occultation when the moon occulted Venus. This is, I think, at the time of reappearance, I think. So occultation would have two parts. One is disappearance, when the object disappears behind moon or any other object, and reappearance when it reappears. So, and eclipses are also very special. People who are even not doing astrophotography, they go to a lot of places just to visit solar eclipses. So in this year, I think 2 solar eclipses are coming up, or even 2 lunar eclipses. So one solar eclipse would be in March, and that is also when the first lunar eclipse is going to be. But unfortunately, those are not visible from India. If you're in, for the solar eclipse, I think you have to be in America, in Europe, or maybe till the western part of Russia to be able to view it. Again, we have another solar eclipse in August or in September. I'm not sure. But again, that is visible, I think, only from South America and Antarctica. So if you are willing to travel, start planning for that. And in September, there will be a total lunar eclipse, which will be visible from India. I think it will begin from 9 o'clock at night, depending on where you are in India, whether you are in the eastern part or the western part. But, roughly it will begin around 9 o'clock, the penumbral eclipse. It will reach totality around, I think, 11 or 12 o'clock at midnight, and it will end around 2:30 in the morning. So, mark your dates if you want to. You don't have to photograph it always, but if you just want to see the spectacle, it looks amazing if you have ever seen a solar or a lunar eclipse. So these celestial events are also a part of astrophotography. And again, most of them are very simple to do. Of course, you can do it even with your smartphone. Optical phenomena, like I mentioned, that it is not a part of the classical astrophotography, but yes, we consider it because it involves light coming from the sun or the moon. So this is an example of a 22-degree solar halo. And this is probably a circumzenithal arc or a circumhorizontal arc. I'm sorry, I don't remember this image, but an arc nonetheless. And we have a lot of such optical phenomena at the sky. And if you just ever look at the sky, you will get one or the other. We say that solar halos are very, rare when it appears or people manage to capture an image. They tend to appear on newspapers or even on news. But let me tell you, these are not that rare. It is just that we at times forget to look up to the sky. And, even from our latitude, I stay at Kolkata from a 22-degree north latitude. I see solar eclipse at least 4 or 5 times every year. It is that common. It is not, of course, you won't be able to see it every day, but it is not that rare as it is projected as. Lunar halo, on the other hand, is rarer, but it is, all these halos are better visible from winter places because the sky is full of those crystals and all. Okay, doing astrophotography requires 3 things, or the 3 Ps, as I call it: planning, photographing, and processing. Again, it would be not possible to discuss all these things together and in detail. But planning involves, first is to, knowing the night sky. So if you're trying to do astrophotography, it is important to know what you're looking at. Nowadays, it is very easy. You don't have to use a star chart or carry a star chart along with you. You can just install these apps. These are just a few examples: Skyview, Mobile Observatory, Stellarium, Skywalk. And you can just, you install these apps, open the apps and just point them towards the sky. And they will show you that what you're looking at, the name of the star or the name of the constellation. If there is a deep sky object, the sun, the moon, and all those things, it will show you. It is also important to know about the seasons. Not every object is visible throughout the year. Say, for example, Orion Nebula is mostly visible during winter. The Milky Way is mostly visible during summer, although you can, see it late at night, right from February also. If you happen to wake up at 3:30 or 4 nowadays, you can see the Milky Way rising. But the best time for Milky Way photography is around May, June, July. These 3 months are considered the Milky Way months. But it is also visible, I think, till end of October, where you will see the Milky Way setting after sunset. When you're planning for an astrophotography trip, it is also important that you know about light pollution. You, of course, have to choose a location which has the least amount of light pollution. Light pollution is, it is understood in terms of bottle scale, which was, I would say, invented by John E. Bottle 20 years ago. So it goes from bottle 1 to bottle 9, where bottle 1 is the darkest sky one can imagine, and bottle 9 is the most light polluted regions, like the cities or the inner cities. So when you're planning, you have to find a location. So there are websites like Light Pollution Map or certain other websites where you can just put the latitude and the longitude of your region, and it will show you the bottle scale, and you can plan accordingly. Also, you need to take care or know about the weather conditions. You don't want to, travel to a place during monsoon when there are high chances of rain and certain things. So if you want the best out of your trip, you want to plan it ahead. The place that you're going, when you're going, what kind of images that you want to take. This is the part of planning. And of course, I forgot to mention is also the moon phase. You need to take note of the moon phase. So the best time for astrophotography is considered, during the new moon, because moon, since it is so bright that it washes away all the details of those faint nebula and stuff. So it needs to be done during the new moon or the week of the new moon. And of course, like I said just now, that you have to decide what kind of images you want. You have to also choose your gear accordingly. Say, for example, I'm going on a trip where my target is to capture, the white field images, the Milky Way or the star trails or constellations. I don't want to pack a lot of telephoto lenses in my bag. I'll prefer to carry wide field lenses. And say if my target is to, take images of the deep sky object, I won't be packing, the wide field lenses. But then again, we can't see that how big the object is or how big these objects would appear with a certain focal length. So to help with that, there are websites like Telescopius or Astronomy Tools or Photopills, where you can just input your equipment details and the object that you're trying to photograph, and it will show you the field of view, that how it will appear in with your particular focal length. And then you can choose accordingly if you want to carry a 200 mm lens or a 300 mm lens. There are certain transits that goes on for with ISS Hubble. Often they transit across the moon or the sun. There are websites like transitfinder.com, which will tell you a month ahead of it that the transit is going to happen. So you can plan accordingly. The apps that I mentioned, the Skyview, Mobile Observatory or Stellarium, those will also show you if there is a celestial event coming up. So for example, the solar eclipses. I'll just show an example if you allow me. And this might seem not very serious thing, charging your batteries, but it has happened with me that I've packed my bag, went directly to the spot, and I found that out of 3 batteries, 2 were not fully charged. And I had to rush back to my homestay and charge them. So it is very important that we check the nuances of everything that we are taking for a trip. So yeah, this is the interface of say an app called Mobile Observatory Pro. And if I just tap on the sky view, it will show me the sky that I have. And I can just, if I move my phone, I don't know if it's visible. Yeah, it will show me the exact what I'm looking at in the sky. And this also has another tab called Celestial Events or the Lunar Eclipses. So if I just tap on the lunar eclipse, it will show me all the list of the upcoming lunar eclipses. And the list goes on. So these are the apps which are very helpful. And most importantly, they're also free. They're not paid. At least most of them are not paid. Some are paid. So you can always take advantage of these apps. These are the things, taking extra batteries, power bank, memory cards. These are also very important. You always have to, prepare for the worst, that your memory card crashes, all those little things, attention to little details. Photographing again. Okay, sorry, but how much time do I have? So I will.
You can continue, sir, for another 10 minutes.
Okay. All right. When on the field begins our second part is photographing. So we normally set up the gear during twilight, when there is still, or maybe during sunset, when there is still light. Because, if you have ever been to a dark sky location, you would know that it's extremely dark. You can't even see your own hand. It is so dark. So it gets very challenging. So we try to set up our gear as early as possible, maybe during sunset. The second thing is we do a manual focus, because like I mentioned right at the beginning that our, anything automatic that the camera or the lens does cannot do it for astrophotography. So even the focusing, we choose a bright star that becomes visible during twilight. We focus on it. There are certain focusing aids like Bartinov mask. Then we do the framing. If you remember that if we have planned for it, we would already know that how to frame the object with the help of those websites like Telescopius or Astronomy Tools or even Photopills. So we do the framing once it is dark enough. To choose the correct shutter speed, like I said, the 3 things we have to decide: shutter speed, aperture, and ISO. So choosing the shutter speed has a specific rule. The rule applies only if you're not using a star tracker. If you're using a star tracker, you can go up to as long as the tracker would allow you to. But if we are not using a star tracker, there is a thing called rule of 500. What is it? That is the maximum amount of shutter speed we can take without having the stars or the object trailing in our frame would be 500 divided by the effective focal length. Say, for example, if I'm using a focal length of 20 mm, a 20 mm lens, so the maximum time I can keep my shutter open would be 500 divided by 20, which would be 25. Yeah. So 25 seconds, I cannot go beyond 25 seconds. But let me also clarify that this is a very, it's a very rough kind of rule. We tend to rather follow rule of 400 or maybe at times rule of 300 when we are increasing the focal length. But for beginners, I think rule of 500 is a fantastic rule. But if you want to be very technical, there is another rule called the NPF rule. You just search on the Google as NPF rule. It will take you to a website. Then it will ask you for certain details like your latitude, your longitude, the object that you're trying to frame, and all those details. And it will give you the optimum shutter speed that you can do. Let me reiterate that this is only for untracked astrophotography. If you're using a star tracker, this is not applicable. You're not bound by any time. It is only as long as your, tracker would technically allow. It can be up to a minute, 2 minutes, 5 minutes, 10 minutes. If it's a very, very expensive or very good tracker, you can go even up to an hour of exposure. Choosing the aperture, if you're using, not using a tracker, you have to choose the largest aperture. If you have a lens which has the largest aperture of say f5.8, it normally is written on the lens. If I have one, yeah. So this is a lens, and here it is written as, I don't know if it's visible. Okay, it's somewhere. It is written here f 1 by 1.4. So 1.4 would be the highest aperture for this lens. So I'd be using, if I'm doing untracked photography, I'd be using the highest aperture to allow the maximum amount of light to my sensor. But if I'm doing tracked photography and I'm not limited by my shutter speed, then I would rather choose a more closed aperture, because the widest aperture is not always where the lens is the sharpest. So if I'm using, say for example, when I use this particular f1.4 lens, the aperture that I personally use is 2.8. I close the aperture because I'm tracking. If I'm doing untracked, I would rather use 1.4 or 1.8. So the second thing that you need to decide is the aperture. And the ISO, there are no right or wrong ISO. You have the shutter speed, you have the aperture. Now you have to take some test shots and check what ISO you need to keep. Say you're starting at ISO 400 or ISO 800, and if the image seems dark, you increase the ISO to 1600, you take another test shot and you see. If that is even not enough, you go up to 3200, 6400, whatever the required is. The goal is to make the image properly lit. Or if you are used to with histogram, you need a good histogram. The peak should be right in somewhere between the second and the third partition. That is the goal that we want to achieve. Now we have a fixed shutter speed for certain lenses. We have a fixed aperture. The ISO is something that we need to play with while choosing the right settings. Processing, it starts with organizing your images in the files once we, come back from a trip. It is also important, I, keep telling people is that, always put a date on your folder names so that if you want to go back, it would be easier on you. There are certain softwares where you can stack images. Of course, in astrophotography, stacking is a very, very important thing because, since we are using very little light to use, for our camera, we take multiple images of the same subject, say 10, 15, 20, 100, and then we stack them. And the goal of stacking is to, or the result of stacking is that we get a better image, better in terms of better noise profile. The noise is reduced, and we also get more detail of the image. So there are different softwares where we stack those images. It does all the alignment on its own. What we all need to do is to just put the images on these softwares. Again, there are separate groups of software for lunar, solar, or planetary images. Post-processing is where we take the images to Photoshop. Again, I've heard a lot of terms or a lot of people asking me if these images are quote unquote edited. Yes, all the images that you see, even the images when you click an image and see on the back of your camera, that is also edited. Photoshopped is a term that is used mostly to mean manipulated image, but we do a lot of post-processing in Photoshop because the images that we get do not look like this, as you're seeing on the background of the image. They do not look even close to that. But with increasing the saturations, the details, and all those things, after all these adjustments is what we get the final image. Having said that, that doesn't mean that we add anything into it. It is the data is already there. We are just extracting it. We do not add these colors. We do not add these details. The details are always there in the image. We just need to extract it or highlight them. There are different dedicated astrophotography softwares like PixInsight or AstroPixel Processor. We also use Photoshop and Lightroom, especially for nightscape imaging. There are certain free alternatives. GIMP is an alternative to Photoshop. Raw Therapy or Darktable is an alternate to Lightroom. And then finally, we save the image as JPEG. And one thing I haven't mentioned is that whenever we are clicking the image with a camera or even with a smartphone, if your smartphone allows it, we always shoot in RAW mode, not in JPEG mode. RAW is an uncompressed version and it keeps all the data. It doesn't compress your data because when we are finally processing the image or stacking the image, we need all those data. If we are shooting in, say, JPEG mode, we are losing those data and we cannot extract all those details from the images. So it is very important that we keep shooting in RAW. And in the last slide, there was a point is that we need to, and when we are processing this stacking, taking it to the other software, this should be done in TIFF. TIFF is another uncompressed file format. So again, we need to keep in mind that we do not want a compressed data in our image. When we are finally putting it for social media or for sharing with friends or even printing, we can save it as JPEG or PNG, which are compressed because we are not working anymore with that data. But as long as we are working, we have to keep working with an uncompressed file format. And it's very interesting that how mobile phones have developed, the cameras and the sensors have developed. And of course, we achieve amazing results these days with any smartphone. But of course, the smartphones that have larger sensors, the better it is. There are certain smartphones that are claimed to be with good low light performance. They are more suited for astrophotography, but that doesn't mean that your smartphone cannot take the images. There is always a way out. Maybe you need to stack more images, maybe 2 or 3 more. By good low light performance, it simply means that the noise profile is better. You can do away even with a 5-shot stack or even a single image. It only means that if you have a smartphone which is not advertised as a good as having a good low light performance, you can there are a way around, and you can always achieve amazing results even with any and every smartphone. Nowadays, smartphones comes with many cameras. I don't know how many. So you see all these cameras, 2, 3, I don't know how many. But using the primary camera, because that is the best one, that should be used for astrophotography. Again, if your camera allows, you can shoot in RAW mode. If it doesn't, don't worry, you can also shoot it in JPEG and get a good image with it. If you're, say, for example, shooting the moon, there are certain lens attachments, which are telephoto attachment, or there are certain attachment that makes the lens wider if your need be. Then you can also add these attachments. So there are some brands like Apexel or Skyweek that produces such lens attachments. Again, there are no universal settings for even with camera or smartphone. All you need to do is experiment. Like I said, if you're considering the exposure triangle, you know the shutter speed. You can find it with the rule of 500 or the NPF rule. You know the aperture. In phone, I think 90% of smartphones do not allow to adjust the aperture. So you know the aperture. The only thing that you need to experiment would be the ISO. If you're considering the experimentation with settings, that is the only thing. And there is no way of telling me sitting in my room that what ISO would be suited for your sky. It will vary from day to day, depending on the sky condition or the light pollution condition. So there are no universal settings as such. These are a few examples taken with mobile phone. This is a star trail image. This is a Milky Way image. And just to iterate that these are not taken by me. These are taken by my good friends in Astronomats Bangla, the group I belong from. This was taken from Darjeeling. This was taken, I think, from Sandakphu or from Al, which is a North Bengal. This is also not by me. This is also from a friend from Astronomats Bangla. This is Jupiter, and both of these images were taken by attaching the smartphone to a telescope. These were taken just with the mobile phone attached to a tripod, and these were taken the mobile phone attached to a telescope. But you can see, how much detail we can see of the Jupiter, all these lines, the great red spot, and the Cassini's division in the Saturn's ring, and all those belts of Saturn. It's amazing. Whenever I look at these images, I find it surprising every time. I think it is important again to mention, because this is not something that when I was not very aware of it until I started doing astrophotography, is about light pollution. It is not taught us in school or colleges like air pollution or water pollution or sound pollution. But nonetheless, it is a kind of pollution, and it is growing. And what it is taking away from us is irreversible. Well, to say it's not irreversible, it can be reversed, but it is, I think, very damaging. Because we don't know where we are. We don't see the marvel of the night sky. It's very disheartening to see what is going on. So with all these artificial lights, the light domes being created in the sky that flushes away all the stars. Just to compare that, I live near Kolkata airport, and I barely could see 30 stars in the night sky on a good or clear night, which is very unfortunate. I don't know what to say about this. And it's, of course, an enemy of not only astrophotographers, but, of human being. Or, we are missing all those things that we could have seen. And not only it hampers the view of the night sky, but it also has a very long impact on the life of human beings and the wildlife creatures. And not to mention, it wastes a lot of energy and money if we all care about. And very importantly, it stops us from enjoying the night sky. But the good thing is, which I said wrong right at the beginning, it can be prevented. It can be prevented by a little more cautious light arrangements, having where it is not necessary, don't put a light. It is just that simple. Switch off your light if required. You don't necessarily you need to have a light for the whole night outside your home. There are street lights. So with the help of some personal um, help from the neighbors, with your personal intervention, of course you need help from the government. It can be prevented. And nowadays, India had its first dark sky reserve at Hanle, which is a very good initiative. India also had its first dark sky park at Pench National Park, which is, again, we are going in a good direction, but we need more of this. We need more of all those dark skies so that we can enjoy. This is just an example of how light pollution affects. This is bottle one. Bottle 1, 2, 3 is excellent for just to even visually enjoy the night sky, or if you are doing astrophotography. Bottle 4 and 5 is okayish. You can take good images, but there will still be a lot of light pollution. Bottle 6, 7, 8, and 9. 6 is again still okayish, but from 7 to 9, you're just seeing it white. As you can see, all these details are just completely washed out. Then there is no way of getting it back. Even with the help of certain light pollution filters and all, they simply do not work in bottle 7 or above. So this is something what we should start caring about, this lights, and especially unnecessary lights. And I think we can, create a better visuals of the night sky for our coming generation. If at all you need to contact me or my group for anything, everything related to astrophotography, you can send us an email, or you can check the Instagram, or we also have our website, astromansbangla.com. You can check. This is something that we say, astrophotographers, we do not, this is equal to best wishes for us. We always say clear skies. Thank you so much. That's it for the presentation.
Thank you, Dr. Soumyadeep, for the interesting facts. Very nice presentations and images we could witness today. We will now begin with question answer session. Attendees can shoot their questions, doubts, and also share your appreciations. Any questions to share? Is there anything in the chat box? Somebody wants to share the PPTs or videos with participants if possible. He's from Astro Society of India, life member of Astro Society of India.
I think the meeting is being recorded.
Yes,
so
yeah,
somebody...
so it should not